Welcome. We are the team tasked with improving acoustics for Aura Hall. I'm Alex Barnard.
I'm Nathan Campbell.
Neil Felixa.
Anna Cat.
In the next few minutes, we're going to explain the purpose of our project, a little bit on the history of Aura, what our findings were, and what recommendations we have to improve the room acoustics of the hall.
In the quiet small town of Aura, the sound of bear hunting dogs can be heard barking over the winter wind. While this town is quiet and peaceful for most of the year, there's one summer weekend in July where the town comes alive with music. Hundreds of people gather to celebrate local folk music in the annual Aura Hall Jamboree, a hall that has been hosting this festival for over 40 years. This festival is held outdoors where anyone is free to play their music or listen to the music of others, and also holds a small indoor hall built in 1914. After discovering that the stage needed to be replaced because of structural bowing, local volunteers responsible for the hall's upkeep worked with Michigan Technological University to establish a spring acoustics project. A project team of 3 mechanical engineering students and 1 sound design major focused on improving the hall acoustics through the renovation process. Though renovations for the upcoming 2016 festival will focus on the stage, the Michigan Tech team studied the entire hall for additional improvements. Before deciding which tests to run to determine the quality of the hall sound, we asked locals who have played music in the hall and who have heard music in the hall what they liked and disliked about the sound quality to get subjective feedback. How would you describe the sound quality of this hall?
We do feel that there is some echo that occurs if you're on stage. If I were to compare it with some of the experiences that I've had, it's not bad at all. It's probably in the top 70–80%. But there is some improvement. That's why we're here talking with you and getting you involved, so that when we renovate our stage, we can make some improvements on the sound system.
A few of the comments pointed out that the hall had an echoing noise when it was not filled with people, and that it was really difficult to hear the music playing on stage for the musicians who were playing in the hall. Here are a few of the specific comments given to us by the people who have attended this music festival.
On a visit to the hall, we began our investigation by making dimensional and acoustic measurements. The dimensional measurements were later used to calculate the room absorption and reverberation time characteristics. The acoustic measurements included a full reverberation study of the hall. In the reverberation study, a pink noise sound source was placed in 3 different measurement locations. A microphone receiver was moved throughout the room at 16 different locations. From these measurements, reverberation times at frequencies from 500 to 4,000 Hertz were measured. When sound is traveling through the hall, it is reflected and absorbed by the floors, ceilings, and people. This diagram shows the incident sound wave that hits the wall, a reflected wave that stays in the room, absorbed energy by the wall itself, and a transmitted wave that would travel to the other side of the wall. To characterize the amount of reverberation, or in simpler terms, echoing, a T60 time is used, or time to decay 60 decibels. As shown in this equation, reverberation is a function of room volume, surface area, and material properties. For instance, a hall lined with carpet might have few echoes, where a hall lined with concrete might have many echoes. To get an idea of what low or high reverb times sound like, let's listen to the following clips. Here's a clip of a reverb time of 0 seconds.
Many factors influence speech intelligibility.
Here's a clip of a reverb time of 0.6 seconds.
Many factors influence speech intelligibility.
A clip of a reverb time of 1.3 seconds.
Many factors influence speech intelligibility.
And the current state of the hall. Small concert halls typically have a value of 1.2 to 1.8 seconds. Engineers can control this time by adding or removing absorptive materials to the room.
In order to find the best geometry and materials to put into the stage area, we modeled in the E software the following. This is an acoustical model of the Aura Hall. Out here you have the audience space, and right here you have the stage. So this was the original setup of the space, And as you can see, this is our meter. So at the back of the wall, you have a high, from the back of the wall to the front, you have a 10 dB difference, which is not necessarily what you want for your performers. It's currently a very loud space, which is why the performers can't hear each other, so we wanted to fix that. This next simulation is with curtains on all 3 walls. As you can see, the color does decrease in tone, so it does cut down the SPL level in the stage by about 8 dB, but you still do have a rather large difference between the front and the back of the stage. This model shows angled ceiling walls and all curtains on the 3 walls. So the SPL does decrease, but you again create a larger gap between the front and the back, and you still have these dead spaces, but you do create a more even toned pattern throughout the stage.
When there's an event like a dinner or a graduation party in the hall, we estimated there being about 25 people. So the reverberation time drops from that high 1.8 down to about 1.4, but there's still a lot of echo in the hall. So the first thing that we're recommending is if you add approximately 1,200 square feet of surface area with curtains to hang them up along the walls in the hall. When you have fewer people in the hall, you can lower that reverberation time and reduce that echo to about 0.8 seconds. The second thing, the team also predicted how sound energy propagates through the hall during the jamboree. So though the sound acoustics are good in the hall for the audience, they're not that great for the musicians. It was found that the natural sound energy created by the musicians bounces around the stage before going to the audience. This could explain why most of the interviewed musicians complained about the hall's acoustics, while the audience's perspective had little issues with the sound. Rather than having a square stage, like the hall did before, we recommend using a more shell stage to bounce some of that sound energy away from the musicians so it's not bouncing around on stage and to get it out to the audience.